Hello, this is a 2-minute brief on the problems associated with using the metric, MTBF, or mean time between failures. It is part of a series of briefs covering advancing semiconductor manufacturing equipment reliability. Let's say that we have 3 identical tools. For the first one, it ran 168 hours, had no failures, but people have often said the MTBF would be 168 hours, which of course, is incorrect. The second one ran for 168 hours, and it experienced 1 failure. Again, we would claim that the MTBF is 168 hours. The third one ran 1,680 hours and experienced 10 failures. Again, we could claim that the MTBF is 168 hours. So, in which case would you have the most confidence that the MTBF is truly 168 hours? This is just one example of the problem with using MTBF as a metric. MTBF suggests a constant failure rate, which infers the failures occur randomly, regardless of how old it is. So, if this is really true, it would not make sense to schedule replacements, or even to do preventative maintenance to prevent a failure. This is the same reason that you don't go around replacing light bulbs in your house if they haven't failed yet. Another interesting question is, what % of a group of the same components will fail by the time they have reached their MTBF? None of them? 50% of them? 100% of them? Actually, it is 63.2%. But of course, you knew that? These are just a couple more reasons that it is not helpful to use MTBF as a metric for the reliability of semiconductor equipment. But don't fear, there is a much better alternative, which will be discussed in another brief. In case you didn't know, Weibull analysis will allow us to look at probabilities, instead of just averages. Stay tuned.